Our first keynote speaker today, Joshua Schuler, who is Executive Director at Lemelson MIT program, and he's here to talk to you about high school invention projects, why and how. So everyone welcome Joshua.
Thanks so much, Kim. Good morning. Is that sound level okay? I don't want to. Yep. All right. I tend to move around a lot during my presentations, so let me know if I'm blocking things too much. Just give a wave. I have a lot of slides to get through because I have a lot of information I want to convey beyond sort of high school invention projects, the why and how. It's sort of what is invention, a little bit about the program I run, lessons learned, things like that. Okay? Very informal. If you have a question, don't understand something I'm saying, or if I'm not making sense, interrupt me. I'm used to actually presenting to high school student audiences who are quite proactive, I'll put it that way, so feel free to interrupt, okay? Now, one of the reasons I came early was to sit in on Anna's presentation, and I was really happy I did that because there were a lot of things that you spoke about, Anna, that I'm going to speak about. And although I do have an agenda right here, I'll give an overview of Lemelson MIT, a few definitions, the why, do invention projects, invent teams. I only have a little bit of time to talk about design for the other 90%, but I'll leave that for Julie to talk about, and also Paul Pollock tomorrow. Next steps, materials, and resources. But before I go into the agenda, of course, I have things to have you do or things to talk about. Now, a few points from yesterday that Anna made that I want you to keep in mind for my talk. Process over product. In education, especially at this stage, high school and younger, you really need to get the students to understand and learn a process. The outcome really isn't that important. It does get the kids excited. They get dollar signs in their eyes when you start talking about invention, but they're learning a process. Student ownership is key. Okay? Projects should be student-driven and be about something that they're passionate about. It needs to be real world. It needs to resonate with them. You guys know this. Multidisciplinary projects are really key because you can engage more than just the science and math geeks. You can engage all sorts of students. Invent Teams is multidisciplinary, so we can engage students from all different disciplines with all different skill sets. That has allowed us to have a gender distribution of over, well, close to 40% female, and it's been terrific to be able to do that. Ask yourself, are you solving the right problem the right way? How do you know? What's the answer to that? Come on. This is supposed to be interactive. I drank my coffee. Come on. How do you know you're solving the right problem the right way? Don had it. Customer. In terms of invention projects and education, I like to use the phrase potential beneficiary. Makes it sound real nice, but it's customer. What's the functional purpose? Anna talked about that yesterday. Don't get too tight. It's not a garbage can. It's something to collect X, Y, and Z. You need to keep it broad, and then it gets narrowed down as the students go through the project. And Anna, feel free to correct me if I'm mispronouncing your name or...
You're right on.
Got it. Good. Teaching students to observe, think creatively, and have confidence is critical, and it's also very challenging. So, how am I supposed to compete with this? All right, there's no elusive D spot in my talk, but I do have something to pass around. These are balls. It would be much better if they were blue, because then I could really go along with the thing. So I want you guys to, take one and pass. There aren't enough, obviously, but take one, pass them all around, and probably midway through I'm going to ask you what they are, and you should be able to figure out what they are. They may be a little tacky, don't worry. Okay. No. And if you're particularly adventurous and really want to figure out what they are, there are some liquids in the other room that might help you figure it out, specifically a one hot H2O, which might help you. Okay. Pop quiz. This is to get you guys going. Have you heard of, and please forgive folks who have seen my presentations before, and please don't answer if you've seen my presentations before. Dean Kamen.
Yep.
Who is he? What's he known for?
Segway.
So, good, perfect. US first, Segway. All right. What else is he known for?
The pump.
Yes. Good. The insulin pump. The insulin pump. Good. So you did both. You did the one everybody knows about, which is a Segway, and then you also did the really obscure one that he really is known for. He's also known for that iBot, and he's been working on this amazing desalination purification water device. He's not known for those. He's known for the Segway. Brilliant, brilliant commercial failure. It's okay. Carver Mead. This is where it usually drops off a little bit. Anybody? That was sharp. Okay, Carver Mead.
Defense for Brazilian soccer team.
The spiral notebooks.
Good high school answer. That's what I usually get. Carver Mead put more transistors on a chip than anybody thought possible. Basically, no Carver Mead, no Silicon Valley, no processors. The videos I'm going to show you wouldn't have been possible without a Carver Mead. Now, without a Carver Mead means if he didn't invent it, somebody else probably would have. But he's a really important person. Very active advocate of education and science. If you ever get a chance to see him talk or go hear him talk, do it. Jerry Lemelson. High school students usually go, Anybody who's not affiliated directly with the Lemelson Foundation. Okay, so Jerry Lemelson is probably one of the most prolific inventors you've never heard of. Okay, I think he's correct me if I'm wrong, number 3 in number of patents? Art? Or up there. 4 or 5, okay, good. 4 or 5 in terms of number of patents. Yet no one's ever heard of him. You probably encounter inventions of his, technologies that he helped develop in some way, shape, or form every day. I'm going to give you a couple examples. Machine vision. This is his biggest invention that he developed. Any guesses what machine vision is? It is exactly what it sounds like. Come on. High school students, guess. Come on, show some.
A seeing eye machine.
A seeing eye machine. Okay, what machines need to see?
Scanners in grocery stores.
Scanners in grocery stores, exactly. Barcode technologies are related to machine vision. What industry uses a lot of robots to manufacture things? Automotive. Okay, so Jerry Lemelson had a lot of inventions related to machine vision that affected the auto industry, barcodes. I mean, every day you go through a scanner, boop. Jerry Lemelson technology was related to that. All right, here's the kicker. Shakira. Everybody knows who she is. Not everybody knows who Jerry Lemelson is. Not everybody knows who Carver Mead is. A few people know who Dean Kamen is. This is a problem. Okay, Lemelson MIT program was brought about to help try and address that. We give out awards and provide recognition for inventors. We want to hold them up as role models. So we have these 3 awards which we give out every year. A $500,000 Lemelson MIT prize to a mid-career inventor. A $100,000 Lemelson Award for Sustainability. That's new as of last year. And we give out student prizes at MIT, RPI, and University of Illinois at Urbana-Champaign, for $30,000 each. Last year's winner, 2006, was Carl Dietrich. This is his what? Is it a flying car, rotable aircraft? It's a rotable aircraft. Okay, it's not a flying car. A rotable aircraft means you can fly, and when the weather gets bad, you land, fold up the wings, drive until the weather gets nice, find a local airport, take off. Flying cars have to fly around, land, take their wings out, drive around, and return to the same airport they landed at, and then take off. This is really cool technologies related to the wing folding and protection of the rotor. Cool stuff. This year's inventor, I don't probably have time to show it, is a rapid ascender. It's a guy who invented basically was challenged by the US Army to do a rapid ascent device to help with military operations, rescue, all sorts of stuff. Really cool. That was the YouTube video I was looking up. If you want to look into it, do YouTube search on Ascend or Ascender or Atlas devices. If I have time, I'll show it. We also have this high school outreach program, which I've been running for the past 4 years, called Invent Teams. It's all well and good to inspire youth by giving awards to adults, getting them to be role models, but it's even better to get high school students and younger even to do invention themselves. That's really the way to encourage them. A few quick definitions. If you want to talk about the sort of spectrum of design, this is where, this is the Lemelson MIT program's view on things. Okay? And we also have some materials about this. Design, you've got problem solving, sort of routine problem solving on the far left. And you've got invention of something novel and useful on the far right, with increasing creativity going on as you go this way. Engineering design, as opposed to just design in general, is about in the middle. Some creativity, some routine problem solving. Invention involves all of that. Here's an easier way, and very simple way, and I think elegant, to think about the difference between the two. Engineering design, what's this? Sunset. Engineering design is sunrise and sunset. Okay? Pretty standard, normal. In between, or as a result of engineering design, you can get some lightning strikes. Okay? That's invention. Make sense? Very simple, I think elegant way of explaining it. Novel, new. Innovation. Often these terms get confused and tossed about invention, innovation, invention, innovation. They're not the same. Innovation means bringing an invention to market, to use. Not all inventions become innovations. Make sense? Nodding, yes? Okay, good. How do you improve the chances of a lightning strike? You need to learn to think differently, and you need to learn to teach your students to think differently. Transgressive thinking, combining different disciplines. Okay, good example. Centrifuges and household appliances. What's that famous vacuum we hear that never stops working? The Dyson, right? Centrifuge and a vacuum. Novel, and it's an innovation. Lightning strike. Insect behavior in robots. I'm going to show you a picture later on of James McClurkin, he's a great inventor, great youth inspiration. He's really keen on ant behavior and bee behavior, and he said, oh, they're basically just running software. What if I program robots to do the same sort of thing? This is transgressive thinking, different disciplines, bringing them together to make a leap. Cooking in liquid nitrogen. Did I spell? Yeah, good. Molecular gastronomy. Standard food, chemistry, which is already involved in food, mixing them together, bringing them together, novel concepts. Get your students to think outside the box, get them to turn the box inside out, get them to think from this discipline and that discipline and combine them together. Why do invention projects in high school? Why not? There's an overemphasis on standardized learning. We all know about those standardized tests, right? Students learn in different ways. Global good, global challenges. If we need a creative society to help the world's problems, okay? At one point this was the US is losing the patent race, or the US is losing in competitiveness. Depending on what audience you're talking to, you have to adjust that one. The role model problem, I like this one. We'll see what you guys think about it. It's fun, and it's real. These are all just basic, simple reasons why you should do invention projects. These pictures on the bottom are from our capstone event, the Odyssey, that's held at MIT each year. These are students during their presentation. These are students after their presentation. You can tell they're smiling. So here's the role model problem. You've got Brittany on the left and Dr. Susan Hockfield, the president of MIT, on the right. So my thought is that if you engage young people in invention and engineering and science early on, they're more likely going to choose Dr. Hockfield over Brittany. And I need to have that updated because Brittany is so far out right now. It's now Shakira. And it's not even Shakira anymore, I think. Hey. All right, a little bit about Lemelson, MIT, and Invent Teams. That's James McClurkin. He's talking with a team that developed a automatic tennis ball retriever. We want to excite students about invention, engineering. We want to empower students through a problem-solving process that's important to them. And we want to encourage a culture in these schools. We do that through grants. We do that through establishing relationships. Okay? Empowerment. This is a team or school, Littleton High School in New Hampshire, that's been involved with us since 2002. Empowerment means you get to implement your project in the front of your high school. This is a radiant heat sidewalk that they developed as part of Invent Teams. Okay? It's powered by solar. It's fueled, or it's heated by it's heated by waste heat from the school's boilers. The pumps are powered by solar power, and it flows through there. So it's implemented, and it works. So these students, their younger siblings, will go into the high school and won't slip and fall on their butts. And there's a lot of snow and ice that goes up here in New Hampshire. This is 3 hours north of Boston, lots of snow. That's empowerment. What's special about Invent Teams for your students? Student-driven, we talked about the importance of that. The students identify a problem that they want to address, not one that you dictate or that one is dictated to them, like a lot of engineering challenges. There's a place for those, but we're beyond that. Self-determined success. What does that mean? Well, it's not a competition. Each invention project is unique. So how do the students know if they've done well? They come up with what's called an invention statement. This is what we want to get to at the end. And how they do based on that is success. Self-determined success is incredibly empowering. Collaboration, not competition. These are teams. Multidisciplinary, I already talked about that. Brings learning to life. Obviously, you're engaged in a real-world problem. Here's a nice one. Any intellectual property belongs to the team. It belongs to the students. You can fight with your principal and school district over it. I'll work with you. I've called quite a few principals and written a few letters. It's always fun talking with a superintendent or a principal who just doesn't get it. We provide up to $10,000. There's a stipend as part of that. And there are follow-on possibilities where it's about a relationship, forming a relationship. What's special about it for you guys, the teachers? Training. At the end of June, we have this capstone event, and this is the first year we brought 35 teachers who were, I guess, semi-finalists for our grants to MIT to experience the Odyssey and go through a few days of training. Pretty amazing, pretty fun. You got free stuff. Access to a network of participating companies like SolidWorks, like Vernier, like IGUS. These are companies that will provide materials, advising, access to MIT alumni, access to MIT resources, access to other teachers who've done Invent Teams. We have Don Domes and Julie Sutphin. You're going to hear from Julie a little bit later. Both of them are alumni Invent Teams teachers. PR and media support. My guess is most high school, middle school, and elementary teachers haven't had media training. Now, one of the things I like to think about for Invent Teams is it's not just for our invention projects. Teachers can use a whole host of tools for any sort of projects that they want to work on. And PR and media training or PR and media tools are great for that. You can apply them to any sort of project you're working on. PDPs and CEUs, professional development points, and continuing education units. Not bad. It was fun to write those letters this year. Stipend, up to $2,000. The capstone event at MIT. Debit card. What? Come on, a debit card. No POs, no purchase orders. You don't have to wait. Invention projects, you can't wait for 2, 3, 4 weeks to get a check cleared through your school system. You want to be able to go on the internet and buy something off of eBay if you need to. And we want you to do that. Typical project categories: consumer products, assistive devices, health and safety, the environment, and affordable tech. The nice thing is, assistive devices and affordable tech are really on the rise in Invent Teams. Students are becoming more aware. Photographs on the bottom, 2 are from the capstone event. One is a team in the midst of working on their project. This team on the far right is Germantown Academy, and they're a lesson in getting to know your customer. So if you were at their demo, you would be hearing right now, Campbell's tomato soup, 8 3/4 ounces, $1.99. They invented a barcode to voice scanner for the visually impaired. Their initial project was a braille to voice glove, and they were psyched about it. And they went to a local school for the blind who they wanted to partner with, and they said, hey, we've got this great idea. We're going to make you a braille to voice device for you guys. They said, we don't need that. We already have something. What we really need, and this is verbatim, is something so that when I go into the pantry, take up a can and open it up and stick a spoon in, I know it's not dog food, because that's happened to me. And it's funny, but at the same time, it's really serious, and it's about independence. So that's what these students did. They made a barcode to voice device, and that's amazing. You know, one, it's great that it included technologies and patents that involved Jerry Lemelson. They worked with stores to gather databases. They worked with Palm handhelds. Really amazing project. First video.
The longer the day, the more recommend. So like if you have
I'm Ryan Bonaker, and I'm from the West Salem High School Invent Teams, and our project was creating a watermelon ripeness evaluator. So as you can see here, we have a decay curve that we recently put up on this O-scope, and it takes quite a while for the signal to decay, and this would indicate a ripe watermelon. And so what we do is we take that signal, which comes from the transducer here, it'll pass through into the circuit right here, and it has an analog to digital converter which converts this analog voltage signal into a digital signal, which is then passed to the basic stamp. And the basic stamp in turn, it has these parameters, so if it's ripe, it has a decay curve of this amount of time versus unripe of the X amount of time. So then it goes to this LED bar display and it displays its ripeness value. And you can kind of see it working here. This is our prototype. It doesn't have the actual circuitry in it, which is the next phase of our invention process. So it thumps, and the value appears on the LED display.
So it's great. That's Ryan Beneker, and Ryan works in a supermarket, and he got tired of people asking him, "Is this watermelon ripe?" So this is the device he came up with. Pretty neat. Now again, it seems like a funny project, but there's a lot of mathematics and a lot of science behind that. Okay. And they went and talked with the customer, and watermelons don't ripen after you pick them. So the initial idea was to use that in the store, but by then it's too late. So they need to really be developing something for a farmer so that when he or she picks them and they go to the market, he or she knows they're ripe. Because if they're not, they don't buy them. Next video.
This is our omnidirectional wheelchair, and it aims to solve the problem of limited mobility in everyday life of a wheelchair user. Actions that everyone takes for granted, like stepping to the side to let another person pass, are impossible to perform in any current wheelchair, and so this design gives an added level of maneuverability that hasn't existed before in any sort of previous wheelchair. And so you get traditional movements like the forward and backward movements, and you also have the ability to turn in your own footprint. But the cool motions in this is that it's fully omnidirectional. So if I want to step to the side to let you pass, I simply push the joystick to the right and it's going to move sideways. So you have an added level of maneuverability that you've never heard of in a wheelchair. The wheels are an Airtrax variation of the Mecanum wheel design, and it has free spinning rollers set at 45-degree angles from a driven hub axle. And what that does is it splits the forces while you're driving into equal X and Y components. It allows opposing forces to cancel out, and resulting forces are carried out because each one of those rollers is free spinning. So you can move in any direction that you need to at any time. And the way that the omnidirectionality works is that it varies depending on the speed and direction of each wheel. So you need to have complete control of the speed and direction of each wheel in order to get the omnidirectional motion. And so we have a custom designed circuit board right here. The input that you give into the joystick is read and input into this control board.
All right, so I use that video to scare people. That's a FIRST Robotics team that's been involved in robotics for quite some time, and that was a project about maybe 3 years in the making. What they did is they took a technology they developed for FIRST Robotics and said, what's another application, what's a useful application we can use this for? And they came up with this omnidirectional wheelchair. The company he mentioned, Airtrax, is a company they worked with outside of Philadelphia to help them go and pursue patents and actually see their invention come to life. It's pretty cool stuff. Just real quick, this year in Invent Teams, we had 20 new teams from 15 states involving well over 250 students. This is sort of the breakdown of the types of projects. Okay. A lot of consumer products, a lot of assistive devices, a pretty good number of health and safety, 2 affordable techs. I'm going to show you, and we also have ongoing teams. So it's not just a one-off process. We want to be involved with you, keep you going, because it takes more than 1 year to do this. We had a really good debrief at the Odyssey this year with all the teachers. And one of the best insights was, at the end of the year, they finally felt like they got it. And if that's the point they're at after a year, we need to stick with them, because now they can really do it, and they can teach other teachers to do it, which is really key for scalability and sustainability and systemic change. So this is one of this year's projects, and this is really cool. This was a team. This is not the team. This was a project by a team in San Juan, New Mexico. Population maybe 500, 600. The school has about, I think, 100 kids in it, and is really shrinking. So what they have there, they have a high level of arsenic in the water in San Juan. So what they did is they developed a filter here, and it has some chemical components in it and a filter. You pour water in, the chemicals turn it red, but don't worry, when you squeeze it out, it becomes clear. So this team worked on this project and got connected with an NGO in Nepal. Field testing, pretty cool. And Julia's going to probably talk about something similar that she and her team experienced. So this is an example of an affordable tech, a design for the other 90%, but it was inspired by a problem right here in the US, too much arsenic in the water. Oh, and it also does some pretty similar things to your team's invention. And we got a little rivalry going, so it's good. So in a nutshell, what's the invention process in high school? Well, identify a problem, develop a solution with the beneficiaries, the customers, and implement. Sounds simple? Pretty simple. Nope. What's going on? All these things get in the way. It's the reality. Now I'm going to take you really quickly through the process, okay? Disclaimer, obviously, there's no right way to do an invention process. This is a way, okay? It's definitely not linear, even though I'm going to show you a linear process. You're going to be doing loops throughout. It's not easy. Failure is part of invention, and it's a required part of invention. Fail early and often in order to succeed sooner. You're going to hear from a guy from IDEO later this week. Ask him about that. He better remember it because it's an IDEO quote. How do we do it? We start off with a setting. In school, extracurricular, build a team, get support. I'm going to go through each one of these about a minute each slide if I have time. Get support, do some brainstorming, gather information, define the problem. That's the invention statement, which we'll get into. Concept evaluation, how you decide what to use, what materials, what's working. Experimentation and analysis, testing and refinement, prototypes and manufacturing. And again, there are loops. This is not necessarily the exact order. It'll shift around. And I've done really messy diagrams of this where it's all sorts of arrows, going everywhere. But this is the straight way of doing it. Setting. In class or extracurricular. It's going to be both, probably. Some teachers have an easier time fitting into the curriculum. Some teachers don't. Access to workspace is key. You need a place to do the project. You need space. Team. How do you build a team? It's not the independent inventor anymore, and it probably really never really was. Okay? Students. What sort of students do you want on your project team? You want the tinkerers, the students who sit in the back and really piss you off because they're sticking the magnesium in the Bunsen burner, because they're taking things apart. You want those students on your invention teams. You want some non-science people as well, some teachers involved. You're building a team not just of students, but also of teachers. You need to have support. Get parents involved. Get community mentors involved. You want a diversity of students, a diversity of skill sets, not all science teachers. Make sense? These projects are multidisciplinary. You need administration buy-in. It really helps. You need community support, not necessarily just money, but just awareness. How do you do brainstorming? How do you do problem identification? Where do ideas for invention projects come from? Here are all the ways. You just ask. Get your students to think. Get your students to observe. I'm making it sound a lot easier than it is. It's not easy. What are problems that they encounter on a daily basis or someone they know encounters? Ask your community. Some projects have come from this, doing a survey of the community. Here's a problem we're having. Serendipity. Maybe a problem will just drop out of air. Again, student ownership is crucial. There was a brochure, a really sort of one-page flyer in the back, which is all about the peer review evaluation process. That's one way of coming up with ideas for inventions. And it's also one way of going through projects and in groups, doing peer assessment and review. And it's really, really useful, I think, and I commonly do exercises using prep with students because if each student comes up with an idea and they pass it to a person on their left, and again, every person is contributing to it, it no longer becomes John's idea or Sarah's idea. It's our idea, and you try and make it better. So check out that brochure, and that's all about that process. Peer review evaluation process. You can use that to generate ideas. I do that, just tell them to come up with a wacky invention idea, and then each one of them critiques it. It helps, believe it or not. Information. You need to learn about the problem. You need to talk with the you need to talk with the customer, the beneficiary. You need to come up with specs. What context is it going to be used in? In a school, in a hospital, out in the field, in a rural Mexican village. You need to know what else is out there. What's the state of the art? What makes your invention unique? Problem definition. This is very important. This is the invention statement. It's also pretty similar to the problem statement in engineering. What is it you're going to invent? It's not a restatement of the problem. It's what you're developing. Concise description of the design challenge and the context. Purpose, that's probably a little small for you to read. To clearly define the problem for the team to focus on and to create a space in which eureka moments can happen. So if you're trying to get something to weigh this much or cost this much, there's going to be a lot of design and some of those lightning strikes happening. It's measurable, quantifiable. And this point up here, I always talk about, well, if you're at an event and Bill Gates is in the elevator with you, or Dean Kamen, or I keep trying to come up with a good female example. Carla, who is the CEO of HP who left recently? Giori, right. So if you're in an elevator with one of these folks, you need to be able to tell them what you're working on. You can't say, I'm building a robot. You need to say, I'm building a robot that's going to do X, Y, and Z, cost this much, help do these things. Measurable and quantifiable. I talked about self-determined success. It's not a competition. How do you know you're doing well? It answers who, what, and where. Team's definition of success. And it evolves. Some teams will have their invention statement all set, and then halfway through we'll go, you know what? We want this to be patentable. So that has to go into it, and that changes things a little bit. Here's an example of an early invention statement. We will invent a device to allow nurses, doctors, and/or technicians in rural medical clinics, et cetera, et cetera. What's missing from this invention statement? Numbers. Quantification. You need quantification. It helps you give targets. Ranges are good too. This will cost between $5 and $10. Fine. This will weigh between 10 and 50 pounds. Fine. Through the course of the project, you'll narrow it down. Here it is later on. Okay, a few numbers added in. So where are the white balls? What are the white balls?
Sugar and cream.
Give you a hint. That's the answer. That invention statement is the invention statement for those white balls. So if you were to take those white balls and put them in some hot water that you made tea in this morning, exactly. Phase change incubation. Throw those in a cooler with some samples, you're good to go. And the reason they were tacky is I left them in my car for a few days and got warm. Okay? So that's an example of an affordable technology, an invention. Amy Smith, who is a recipient of the Lemelson MIT Student Prize, invented those. And she's also invented a number of other things, but it's really cool. Use phase change technology to incubate. I'm fascinated by this. This is really cool. Isn't it? Yes. Good. All right. Concept evaluation. Here's a tool you can use. It's called a Pew chart. So let's say you're trying to think about you have this idea you need to do an incubator, lab incubator for use in developing countries. How are you going to maintain the temperature? Well, you can do a battery. That's sort of your control. You can do solar power. You can do this phase change thing. Or you can do a water bath. You can also do this for what sort of material you want to use. And not for this, but you want to make something out of glass, out of aluminum, out of wood, and you just do a process through it. And you come up with evaluation criteria for it. Cost. Obviously for affordable technologies, cost is a big deal. So you can weight things accordingly too. Reliability, accuracy, maintenance, safety, ease of use. And you just total it up at the bottom, and whatever one has the highest is the one you go with. Can it change? Yeah. You want to consistently review it, go back to it, see how you do. Something new might come up. You might learn about a different sort of technology or material that you can use. This goes by a lot of different names. Pew chart is just what we call it. I think there are a number of other names for it. But this is a pretty useful tool, and it's pretty simple for students to understand. I hope, right? Testing and refinement. So you build it. You build some prototypes. This is that team up in New Hampshire. They built a concrete slab in the back of the school, and they melted some snow. Prototypes and manufacturing, these two really go together. So you can see how they were heating it. So they heated the slab, melted snow. Happy student. Results. So again, this is what it ended up with. What they ended up with. And there's a great video of a snowstorm. I don't have enough time to show it to you, but it shows a snowstorm. And the snow comes in and it melts off, and the areas that don't, and you see a guy come out and shovel. It's great. But it works. It works. Lessons learned. Any questions so far? Yes. That means I have 5 minutes left. Shoot. Okay. Lessons learned. I'll go through this quickly. All right. You want the tinkerers. We talked about that. You want students with diverse skill sets. Teachers, you need a team too. Because if something happens to you, you don't want the experience to go away. Try and combine, team up with a technical or shop teacher. A lot of high schools don't have shops anymore, or machine shops. Find somebody. Get parents or mentors involved. You never know whose parent is going to be, have some funds or be a patent attorney or know somebody who knows somebody. Team structure. Think about subgroups. Design, build, documentation, very important. Think about student leads. You're going to need somebody to take the lead and be a project manager, somebody to handle the finance, somebody to handle the PR, somebody to handle all the administrative paperwork. Team size. 8 to 12 is probably good as your core group. You may have something bigger, but you'll end up with a core group of that many. Things happen. You got to prepare for attrition and have students able to cross-train. Now, Don did a really good study, I think this is right, 150 hours minimum to get to basically an alpha prototype to have at our capstone event. 150 hours. That's a lot. If you want to get to full-fledged, ready-to-go prototype, I think it goes up to in the 600s, 700s. Think about credits, community service. Idea generation needs to be relevant. Students need to be passionate about it. It needs to be an application. This is, again, the omnidirectional example. Find new applications for existing technologies. You got to practice. You can keep doing that prep thing in small groups. Generate ideas, critique ideas. It's a healthy process. Really quick. Build early so you can break it. Order more than you need because you'll break it. And you don't want to wait because students waiting around equals death. You don't want them to get bored. They've got so many other things they should be doing or could be doing. Food. Don's team holds the record in number of pizzas ordered. It's amazing. My first year at the position, I got this budget request for Twinkies and Doritos, and it's great. With the amount of hours students and you are putting in, it makes sense. Food is part of it, and we actually, we want you to purchase food with the grant funds. Mindset, fail early in order to succeed. Whoops, succeed sooner. So basically, I should have developed that slide a lot sooner, and I would have noticed that I misspelled that. You're doing something good. Toot your horn. Get the word out. Be proactive. Pick up the phone. I know too many teachers who are afraid or don't know how to pick up the phone and call a company or call the local media. Or, just do it. It's a good thing you've got. Visit a company. Get parents involved. Customer knows best. Engage them early and frequently. If not, your students will have a very humbling experience, which is a very good learning experience as well, though. And back to this sexual innuendos, this is not a one-night stand. This is a long-term relationship. And quickly design an event for the other 90%. Here's how you can get other students to think about it. You need to expose students to the other. Okay? There's sort of a range or a continuum of altruism in students and how they think about projects. First, they usually think about themselves and dollar signs and consumer products. That's great. Then they may be getting to think about others, which might be environment, health and safety. Then they start thinking about somebody else who may be having a more challenging life, assistive devices. Then they may think about affordable tech. Affordable tech can occur in the US, it can occur in a developing country. In order to generate this sort of emotional change and get them aware, there are things you can do at home. Get them to volunteer. You can get them to live on $2 a day. There's a class at MIT led by Amy Smith who developed those incubation phase change balls. The class, including the teacher, lives on $2 a day for a week, minimum. Yeah, it's worth trying to really give perspective. You can do classes on culture and on issues. If I have time later on today, I'll talk about D-Lab, which is a class Amy teaches, which is about basically a 1.5 to 2 years class, in which they learn about the culture, visit the country, work with them, develop inventions, go back, test them. Very similar to what Julie's team did in high school. If you can travel, like Julie's team did, it's great. I don't have enough time to talk about Saul, but basically he invented low-cost eyeglasses because he found it really silly to bring these charity glasses to people and they wouldn't fit right, they wouldn't look right, people wouldn't wear them. You can't travel? Bring it to you. There's plenty of technology, there are plenty of universities. MIT is just one university that's involved with this sort of stuff. And there are organizations out there, Design That Matters. And it's either Engineers Without Borders or Engineers for a Sustainable World. Great organizations to connect with if you're interested in affordable tech, and I assume you kind of are. What's next? Apply for Invent Teams. I would love to have applications from you guys. They'll be available online this fall. And there are materials which you probably picked up on the way in. The best one in there is, well, I shouldn't say that. One of the most useful things in there is the list of resources available from MIT, which lists a whole host of programs and sort of references that you can use, including OpenCourseWare, including the MITES program, which is a great summer initiative, and probably even an Athena account, which I'll set up for you guys, which will allow you to use MIT's resources, online resources, the libraries, databases. Okay? This is where I would ask for questions, but I don't know how much time we have for questions. Okay. It's my contact info. Questions? Did I go too quickly? Okay.
Is there any plans for having the program at the middle school level?
Very good question, and I often get asked that. What I typically say is, you have a high school near you, right?
I do. Yeah.
Team up with them. You could have an invention project for a middle school. Like it's a problem or an issue in the middle school. They can develop an invention for it with them. It's a great idea. Other questions? Oh, come on. Yeah, who's sure?
Josh, you talked very little about the sort of the people problem side of it, and from running an equivalent or participating in an equivalent scheme in the UK, we found that one of the difficulties, and I'd be interested to hear how you handle it, was putting together teams that work well together amongst the kids.
Right.
We tried, well, the way that we found most successful is that we run a kind of pre-competition where groups of 2s and 3s will put together very short, sharp presentations on ideas.
Right.
And then from there, we kind of put teams together.
Right.
You talk a bit about the people problems.
Right. There's certainly the teams, the Invent teams encounter the same issues. We tend to have them or encourage them to weed out the folks who aren't contributing. What do we do in advance? Well, we try and encourage the teachers to do things like you suggested. We encourage them to talk with the students and figure out what it is they want to do. In terms of idea generation, you could do that. Don's team generated a whole bunch of ideas, and they actually applied with quite a few. And based on the idea that got picked and all, you have sort of a weeding process going on there. But it's tough, and honestly, that's sort of part of the experience too, is to have a dysfunctional team. And getting high school students to work with a dysfunctional team and talk with the team member who is not pulling his or her own weight is great. And if the teacher can facilitate that process, that's an amazing learning experience too. And that happens in the real world. I mean, you know how it goes on engineering teams and teacher teams. Whatever you're working on, you're going to have folks who aren't necessarily in the same bus, going in the same direction. It's not I don't think I'm answering your question completely, but it's sort of, that's what the reality is. And we want...
Isn't any kind of company structure? The UK's...
Yeah, I'm sorry. So we sort of talk about, it really depends on the school and what their comfort area is and what the teacher's comfort is. We sort of will encourage there to be a design team, a build team, a finance person, a student lead, a PR person. So we do sort of make suggestions. We don't require it though, because teams are of different sizes. We have teams as small as 5 or 6, which is really too small, and we have teams as large as 30. But we say, these are some things that we know have worked in the past. Breaking up according to teams, and a very important part of it is, if you have these subgroups, you need to have an executive group that floats, where you have one person from each subgroup go, so that, because integration, as you probably know integration at the end is a real issue. It's great, all these silos are working great on their project, but then when it comes time to integrate the software and the hardware, and that's a real world problem too. That happens all the time. We let them have it out. In the back.
Have you been able to do any early assessments of the effects on the students after the experience?
It's a great question. We've been doing surveys at the beginning of the experience and at the end. And what we've found so far is they're really excited about it. They see themselves as being inventors. And they see themselves doing more with it, either that specific project or other projects. Again, it's about process over product. The neat thing about the Lemelson Foundation is they have a lot of grantees. And the gentleman who just spoke is from the Smithsonian, the Lemelson Center. I told you I would get it wrong. The Lemelson Center at the Smithsonian. There's also another grantee in Western Massachusetts called the National Collegiate Inventors and Innovators Alliance. So there's a pipeline. We provide grants to high school students, and the NCAA provides grants to college students. It's about a process. So we know we've encouraged them, they've felt empowered, they've gotten excited, and there's a path to follow. So there's a path to follow up. What we need is a path to go down, and that's what this the Lemelson Center at the Smithsonian helps with. Yes, Tricia.
I just wanted to add that at the Smithsonian, we've done some work with an event team locally from Washington, D.C. And we had them participate in an event in March, and we had this little private lunch with them and an inventor afterwards, and we got them to talk a little bit about, you know, what has the invent team experience done for them? And I mean, it was incredible. It was really inspiring because, you know, they said things like, well, you know, before, you know, I kind of thought maybe I'd go to college, but now, like, I know that that's an opportunity. I'm going to do this. Well, I mean, it really changed the way they thought about themselves, the opportunities. And these were kids, you know, from an urban setting, not a lot of opportunity. And what the teacher also said was that it not only changed the way these kids thought about themselves, but it changed the whole culture of their school.
Right.
Because even kids that weren't involved saw what these students were doing and saw the opportunities, and so all of a sudden these other kids saw that there were opportunities for them that they didn't know existed before. So it was just, I mean, you know, we wish we could just bottle that. I mean, it was really amazing.
So I'm going to make two quick comments, and then I know we should move on. We often get asked, one, is this a recruiting tool for MIT? No, it is not. So it's a sensible question, but it's an easy answer. It's not. It's a recruiting tool for any engineering or science discipline in the future. Okay, anything. Two, we get asked, you know, is this only AP kids who are involved? No, not at all. And it's really great to hear stories like Tricia's just told us about, because we have a few Votech schools each year. We have a few non-high-flying, high-academic schools, and they do really well at these things, and it opens up the world to them, and that's amazing. And they do tell us about it. Thanks. Last. Yep.
Yeah. One thing that kind of, you know, made sense when you said when a project goes dead, and I just feel like that's when the student motivation, when the student hears invent, you know, they jump on the bandwagon. And one thing as a teacher, do we do some preliminary research? Because I'm just thinking, you know, being from New York City, you know, trying to go to certain companies, you might literally get the door slammed in your face. Do we want to go through that, or do we have the students kind of go through it?
It's a very good question. You have a couple things to help you. You have our name, which very often becomes just MIT when you're talking, and that opens some doors. A good technique for sort of plowing the way for your students is, yes, for you to call, get through to somebody who is receptive to a student calling them, him or her, and say, look, you know, a student's going to call you this week. So-and-so is going to call you this week to talk with you about this. You sort of make the path for them. That helps. That helps. You shouldn't be shy about doing that, and the student shouldn't be shy about doing that, because they'll follow your example, I think. All right? Oop.
I was wondering, you said, and I totally support that, make mistakes early during the project so that then you won't stumble into something else. Most of us know what are the common denominators for success in a project. But what about what happens, or what are the most common denominators for failure in these projects?
Dysfunctional team, running out of money, not having parts, not having components.
Technology.
What's that?
The technology.
The technology to support the project, and administration to support the project, space to do the project. It's all the things. If you think about a startup company, it's all those same things. You need the people, you need the space, you need the money.
And when this project is being done with invent teams, because I suppose that generally when you apply to do an invention with there is a certain rate of success and a certain rate of failure.
But this is a process. So how do you measure success? It's self-determined success on the part of the students. If they show up at the Odyssey, our capstone event, and they're proud of what they've done, that's a success for them. And if they've learned something, that's a success. This year we had a team that was not successful, and 2 weeks before the capstone event, I had a very long conversation with the teacher and the principal of that school, and we decided, you know what? You're not ready. The students will not be proud of what they've done. They don't feel they've been successful. Okay, let's have you come next year and work on it between now and then. It's the best answer I can give. All right? Thanks so much. I'll be here all day.